The MouseWorks Munchies Monitor project was designed to collect data from remote sensing units using a quad reporter base station, which could be chained with others to collate data points with a computer through USB. The remote sensors are modular units with RFID and load cell readers, though the next version will also include stepper motor control. The first iteration of the reporter was a monolithic board, but we've since moved to a modular architecture that includes a daisy-chainable USB Type-C module, the main microcontroller board, and the remote sensor manager, which uses differential signaling to communicate over long wires while powering up to 6 units and their peripherals. Assembly of the reporter is simply a matter of stacking the modules to form a 3-layer sandwich. Though taller, compared to the original unit, these have a much smaller footprint. Another advantage of the layered approach is that we can swap out subsystems easily. Here's the original USB layer, based on the pretty terrible Vinculum 2. The new USB modules, built around the FT906 chip, are more powerful and reliable and actually have a smaller part count. To demo the entire system, the components were prepared and assembled. These included the hex reporter USB, microcontroller and sensor control modules, a set of remote sensor units along with their modules, the RFID and load cell readers. To ensure a demanding testbed and show off the reliability of the differential signaling, long cables up to 3 feet were used. The RFID readers were placed very close to each other, and I generally tried to make a mess of the cables to ensure maximum interference. While the system is running, it will detect the tiny RFID chips and transmit its findings by outputting a CSV entry through the USB serial port. Here you can see my actions along with the output on the serial terminal. Notice that there's built-in hysteresis once a tag has been detected, such that jittery mice won't cause an avalanche of spurious data points. Once the tag is distanced from the reader, a few subsequent empty reads let the system know that the subject is truly gone and an exit line is output. At this point, the project objectives haven't met and I could have called it a day. But as specified, the scope leaves the user blind and powerless. Sure, data is received, but it's hard to tell what's going on with the system and impossible to configure, so I expanded the project and added in a Device Druid interface. Device Druid, available through the Windows App Store, provides a simple way to give embedded devices a graphical interface. Once installed, you can launch Druid while the reporter is connected through USB. Device Druid will detect any USB serial devices, including the hex reporter. Connect to the module, and Druid will scan the reporter to figure out an appropriate user interface. Here I've set up a number of elements. The most elementary is the status button, which gives you info on how the hex reporter sees the world and its own sensor units. Those sensor units are smart enough to tell the reporter whether they've been configured, which you can do in the Setup submenu. The first thing to do with a freshly installed hex reporter is to set the system time. With this bare-bones interface, you must enter the Unix epoch directly. The current value can easily be found on Linux machines or online. Get the current value, click the SysTime button, and enter the fresh value to set it. This system time will now be used during data point generation. The other important setup function is the load cell calibration. For this, first set the weight you will be using for calibration in grams. You want to tell the sensor unit to tare and reset for calibration. Select the sensor unit you're calibrating using the slider. Clicking Reset Calib will tare the targeted BSU. Wait a few seconds. Finally, place the calibration weight on the load cell and let it settle. Now hit the Calibrate button and give it approximately 10 seconds without disturbing the setup. After that, you can head back to the top menu and check the status of the modules. The interface has other functions which are relatively self-explanatory, but will be detailed in the documentation. And so concludes the Munchies Monitor demo and the hardware phase of this project. I hope you enjoyed it and will get back to me with comments and questions. 再见!